Exploring the Anthropic Principle. Imagine stumbling upon a lock that opens with a key made of a billion tiny, precisely arranged pins. Each pin must align flawlessly for the key to turn. This analogy mirrors the staggering complexity and exactness of the universe we inhabit, where numerous physical constants and conditions align with an eerie perfection to support life. This peculiar alignment fuels a profound question: is our universe custom-made for our existence? This inquiry forms the bedrock of the Anthropic Principle, a concept that suggests our universe's physical laws are finely tuned to allow life to emerge. This essay delves deep into this principle, exploring whether we are mere cosmic accidents or the inevitable products of a tailored cosmos. Imagine stumbling upon a lock that opens with a key made of a billion tiny, precisely arranged pins. Each pin must align flawlessly for the key to turn. This analogy mirrors the staggering complexity and exactness of the universe we inhabit, where numerous physical constants and conditions align with an eerie perfection to support life. This peculiar alignment fuels a profound question: is our universe custom-made for our existence? The Anthropic Principle posits a universe finely tuned to host life. It splits into two forms: the weak Anthropic Principle, which observes that we must find ourselves in a universe capable of supporting life, and the strong Anthropic Principle, which suggests the universe's properties are fine-tuned for life. This principle has profound implications in cosmology, providing a framework to discuss why the constants of nature, laws, and conditions of the universe allow for the emergence of life. The Anthropic Principle challenges our understanding of the cosmos, mingling the borders between science and philosophical inquiry. It raises a fundamental question: are the favorable conditions in our universe a result of sheer chance, or do they imply some deeper truth about the cosmos? Cosmological constants, such as the gravitational constant and the cosmological constant, are crucial for the existence of life. These constants have values finely tuned to an astonishing precision. For instance, if the cosmological constant were slightly different, the universe could either have expanded too rapidly for galaxies to form, or have collapsed back on itself too quickly. Imagine baking a cake with a recipe that requires precision down to the milligram. Slight deviations in the ingredients can lead to a culinary disaster. Similarly, the universe's constants need precise tuning, akin to this meticulous cake recipe, to support life. The universe operates under the influence of several fundamental forces, including gravity, electromagnetism, and the nuclear forces. These forces are perfectly balanced to allow the formation of atoms and molecules, the building blocks of life. Without this delicate balance, the universe would be hostile to any form of life. Consider a house of cards, where each card's placement is crucial. A slight misalignment could bring the structure crashing down. This analogy illustrates the critical balance of forces in the universe, necessary to maintain a stable environment conducive to life. The multiverse hypothesis introduces the idea that our universe is just one of potentially many universes, each with different physical laws and constants. This theory helps explain the fine-tuning of our universe by suggesting that we are simply in one of the universes that accidentally got the right conditions for life. Think of the universe as a winning lottery ticket in a draw with countless entries. Just as only a few tickets win, only a few universes in the multiverse may have the right conditions to support life. Our existence in such a universe might just be a matter of cosmic luck. Biocentrism argues that life and consciousness are not just incidental cosmic occurrences, but central to the universe's very nature and laws. According to this view, the universe is tailored in a way that makes life not only possible, but inevitable. Imagine a video game designed specifically for player engagement, with environments and challenges crafted to ensure an engaging gameplay experience. Similarly, the biocentric view suggests the universe is designed to support life, akin to a game tailored for its players. The concept of the Goldilocks zone describes the habitable zone around a star where conditions are just right for life to potentially thrive. Not too hot, not too cold, but just right. For a planet to support life, it must reside within this zone, where liquid water can exist and the climate is suitable for life as we know it. Imagine searching for the perfect spot in a forest to set up camp. Some areas are too exposed, others too shadowed, and some just right with the perfect mix of sunlight, water supply, and protection. This analogy parallels the precise conditions needed in the cosmic campsite of the Goldilocks zone, highlighting the delicate balance required for planetary habitability. Quantum mechanics plays a critical role in the fine-tuning of the universe. Quantum fluctuations in the early universe greatly influenced the formation and structure of the cosmos, impacting the development of galaxies, stars, and eventually, life. Consider the universe as an intricate jigsaw puzzle. Each piece must fit perfectly. A single misplaced piece could distort the entire picture. Quantum particles and their interactions are like these puzzle pieces, where even the smallest elements must align precisely to create a universe capable of supporting life. While the anthropic principle presents an intriguing perspective, it has faced significant criticism. Critics argue that observing fine-tuning might simply be a result of our position within the universe. We observe conditions conducive to life because we are here to observe them. Others propose that multiple universes or natural selection among universes could explain the observed fine-tuning without invoking design. The analogy of finding a perfectly shaped pebble on the beach can illustrate this debate. One might think it was shaped with purpose, while another might argue it's merely the result of countless waves and natural erosion. This represents the ongoing debate about whether the universe's conditions are purposefully set or simply a result of natural processes. The anthropic principle straddles the boundaries between science and philosophy, asking deep questions about reality, existence, and our place within the cosmos. It challenges us to consider whether the universe has a purpose or intent, or whether we are mere observers in a vast, indifferent cosmos. Imagine the universe as a grand theatrical play. Are we merely actors following a pre-written script suggesting a designed and purposeful cosmos? Or are we improvising with no script, indicating a universe governed by random events and natural laws? This analogy helps explore the existential implications of the anthropic principle. As scientific understanding and technology advance, the anthropic principle continues to be a topic of intense research and debate. Future discoveries in physics, astronomy, and other fields may provide further insights into why our universe has the properties it does. Think of our quest to understand the universe's fine-tuning as an ongoing detective story. Each new scientific discovery is like uncovering a new clue that could potentially solve the mystery of why the universe is conducive to life. This analogy underscores the dynamic and evolving nature of scientific inquiry into the fundamental questions posed by the anthropic principle. Dark matter and dark energy play crucial roles in the structure and evolution of the universe, influencing the formation of galaxies and the universe's overall fate. These components act as the invisible scaffolding of the cosmos, essential yet unseen. Imagine a building where the structural supports are hidden within the walls. You cannot see these supports, but they are critical for the building's stability and integrity. Similarly, dark matter and dark energy are the unseen forces that hold the universe together, crucial for its structure and hospitability for life. Carbon is a key element in the chemistry of life, known for its incredible versatility in forming bonds with other elements. This capability makes carbon the backbone of organic molecules, from the simplest gases to complex DNA structures.
Think of carbon as a universal building block, much like a Lego piece, which can be used to construct creative structures. This versatility is crucial for the diversity of life. Carbon is a very force to develop these carbon-based building blocks.
DNA is an intricate molecule, encoding the genetic instructions essential for the development and functioning of all known living organisms. The complexity and precision of DNA are fundamental to life's diversity and complexity. Consider DNA as a detailed instruction manual for building a complex machine. If the manual is incomplete or incorrect, the machine cannot function. Similarly, the precise information in DNA is crucial for the biological processes that sustain life, underscoring the fine-tuning necessary at the molecular level. Water is often termed the universal solvent because of its ability to dissolve a wide range of substances. This property is vital for life, facilitating countless chemical reactions and biological processes. Imagine water as a key ingredient in a complex recipe, necessary for blending various components into a cohesive mixture. In the same way, water's solvent properties enable it to support life by allowing the mixing and interaction of different chemical substances within organisms. Gravitational forces are not just about keeping our feet on the ground, they are the architects of cosmic order. They determine the orbits of planets, the formation of stars, and the dynamics of galaxies. For life to exist, these gravitational forces need to be exquisitely balanced. Too strong and planets would crash into their stars, too weak and they would drift into the cold abyss of space. Consider a ballet. Each dancer's movement is precise, their timing impeccable. One misstep and the performance falters. This is akin to the gravitational dances of planetary bodies. The rare Earth hypothesis posits that planets like Earth, with conditions suitable for life, are exceptionally rare in the universe. This hypothesis suggests a convergence of various astronomical and geological conditions that are just right for life, much like a perfect storm. Imagine discovering a gemstone in a vast desert. Its creation required a unique set of conditions: right temperature, pressure, and elements, all at the right time. Earth, similarly, is that gemstone in the vastness of the universe, formed through a rare alignment of conditions that has yet to be replicated in our known cosmos. The Anthropic Principle carries significant implications for the search for extraterrestrial life. If our universe is fine-tuned for life, what does that say about the existence of other life forms in the cosmos? The ongoing search for planets in the habitable zones of distant stars aims to answer part of this question. Imagine astronomers as cosmic detectives, combing through the vast expanses of the universe looking for clues. Each discovery of an exoplanet is like finding a needle in a cosmic haystack. By understanding the conditions that support life on Earth, scientists hope to identify similar conditions elsewhere. Stellar evolution plays a crucial role in the cosmic fine-tuning narrative. The processes within stars forge the essential elements for life, such as carbon and oxygen. The death of stars often leads to the creation of new star systems, potentially with habitable planets. Think of stars as cosmic factories. Within their fiery furnaces, simple elements are transformed into the complex elements needed for life. When these stars exhaust their fuel and explode, they scatter these elements across the galaxy, seeding the potential for new life-bearing worlds. There is a growing dialogue among some scientists about whether consciousness itself is a fundamental component of the universe's fabric, influenced by the Anthropic Principle. This perspective suggests that consciousness is not merely a byproduct of complex neurological processes, but a driver of the universe's unfolding. Consider the universe as a stage and consciousness as the light that illuminates it. Without consciousness, the universe, like a stage unlit, remains devoid of observed meaning and depth. Thus, consciousness could be seen as not only arising from the universe, but also giving it form and significance. The future of fine-tuning research looks promising with the advent of new technologies. Advances in telescopes, particle accelerators, and quantum computers will provide deeper insights into the fundamental forces and constants of the universe. Imagine future technologies as more powerful microscopes and telescopes combined. Not only can we see deeper into the space around us, but we can also look more closely at the fabric of reality itself. These tools could eventually unveil whether the fine-tuning of our universe is a mere cosmic coincidence or the imprint of a deeper cosmic necessity. As we delve deeper into the complexities of the universe, the Anthropic Principle serves as a pivotal framework in our quest to understand our place in the cosmos. Whether it points to a universe custom-made for life or a fortunate set of cosmic circumstances, it undeniably enriches our exploration of the fundamental questions about existence and the nature of reality. Through scientific inquiry and philosophical reflection, we continue to unravel the mysteries of why our universe exists as it does, and perhaps why we are here to witness it.